Today we're looking at Nvidia's new model called Nemotron. It's based on Llama 3.1. It's a 70 billion parameter model. And yeah, let's check it out. This is the interface on the Nvidia website. And this is my first time playing with it. Let's see what it can do. Not terribly impressed with this UI, but this is just meant to, be an experimental thing. And let's get to it. Looks like we can get an API key if necessary, and this would be the setup for what we're interacting with here on the left if we wanted to implement this in our local environment. For now, let's just go ahead and use this. It has some helpful hints here. Let's write a limerick about the wonders of GPU computing. Well, it is very fast. Wow. Here's a limerick about the wonders of GPU computing. There once was a GPU so fine, whose computing powers did shine. It crushed with great zest through tasks that were a test, accelerating all in its prime. How sweet. All right, let's do something a little more challenging here. This is a classic question that many people are asking various models, so let's go ahead and try this. How many R's are there in the word strawberry? Now, this might seem like a very simple question, and it is for most humans who can read. However, due to the fact that models are not actually interacting with words the way humans do, instead, what they see are tokens. More specifically, what they see are numeric representations of tokens, and tokens are fragments of words. Okay, so this is actually a really challenging question for most AI models, and a lot of them get this wrong. Let's see what it does. Okay, so a quick and juicy question. Interesting. Let's count the R's in the word strawberry, and it lists them out here, and it gives the right answer. There are 3 R's in the word strawberry. Okay, fantastic. That is definitely a pass for that one. Let's give it something even more challenging, and this is challenging for a very similar reason about why it's difficult to count letters in a word. I want it to count words in an answer to this question. Let's see what it does for this. Again, this is just really fast. Oh, interesting. Okay, so it's counting the words in its previous answer. That's not quite what I intended, but let's see what it says. There are 21 words in my answer to the original question. Note, I excluded the star symbols and the number 3. Okay. Oh, and it counted the number 3 as a word, even though it's a number since it's part of the sentence structure. Okay, well, that makes sense. Let's reset the chat and ask that again, because what I really want is the answer to this question, and I want to count those words. So let's go ahead and send that off. Interesting. Okay, I don't like this UI very much. It's just very compact. A delightfully meta question. Cute. Since I haven't written an answer yet, there are currently 0 words in my answer to this question. Interesting. Very interesting take. It's actually kind of wrong in a way because, even this is part of its response. I did say answer, which might have been a little confusing. Let's move on here. However, if we count the words in this response, including this sentence, and then it counts all of the words, very interesting. 36 words. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 36. 36. I'm going to give that a pass. I think that is a really good answer. Now, it didn't count all of these. Okay. And it didn't count any of these words. So, yeah, I'm a little split on this one. But this is a valid answer. Pretty good so far. Let's see what we got next. Okay, for this next test, I think I want to switch over to Python. Let's go ahead and switch to PyCharm here. All right. I have the code set up. This is just a copy and paste from the Nvidia site. All default settings here. The one thing that I want to change is the max number of tokens returned, because the next thing I want to try to get it to do is write some code for us, and I'm not sure 1,000 tokens is quite enough. So let's go ahead and bump that up. Yeah, let's go 4K. So 1024 times 4. And what we want it to do is write the snake game in Python. Oh, helps to write. There we go. No spelling errors. There we go. Let's see what it does for us this time. Well, I have to say, this is really fast. And of course it is, right? I mean, this is running on primo Nvidia hardware. Of course it's fast. It is a 70 billion parameter model. If I were to run this locally, it would be super slow. So let's go ahead and grab this code. And create a Python script. Let's call this game. Paste that in. We will have to do a couple of imports. We'll have to install the imported Pygame. Looks like it did an import here of time that it doesn't need. There's also a few things that, yeah, my IDE isn't terribly happy with the syntax, but that's not an error per se. Wonder why it put parentheses around that. Those are redundant. Yeah. It looks pretty reasonable overall, though. Up, down, left, right. What's it saying about this? Local variable new head might be referenced before assignment. Ooh. That's not good. Well, let's go ahead and run this and see what happens. Gotta change my screen share over to the snake game, and it's running. I don't have control of the snake, however. It's unfortunate. Let's go ahead and set the code. Yeah, it's supposed to be using the arrow keys, but they were not functioning properly. So it didn't manage to get the snake game quite perfect, which is understandable. This is actually a very difficult thing to get right on the first try. I'm sure with a little coaxing, we could probably get better results. However, we're on to other things. I hope you enjoyed this, and I'll see you next time for a deeper dive into the new Nvidia model, which is Nemotron. All right. Thanks for joining. I'll see you next time.